Okay, everyone, I quickly just repeat the lesson of multiplication of vectors. We have dot product or scalar multiplication because the result is a scalar, and you can change the order or displace the vectors. They're deal with cosine, and of course when you displace them, you have theta here or negative theta here. Of course, the theta is the one that goes upside. This is the theta, and this is the negative theta. And you can see your theta and negative theta in your unit circle. You can easily see that if you draw a perpendicular here to the cosine, this would be the cosine of it. If you draw a perpendicular of negative theta here, this would be the cosine. The cosines are equal, therefore not only these parts are equal, these parts are also equal. So you can do that, and these are equal. And you can see in here that the bigger the angle gets, of course, this is the smaller angle, and this is the cosine of theta, and this is the bigger angle, then this would be the cosine, which gets smaller. So the bigger the angle gets, the smaller the cosine gets. So the bigger the theta gets, the smaller the result gets, the smaller the c, which is the product, will get. So now let's look at the cross product. A times b equals c. In this case, c is a vector, and this multiplication also is called vector multiplication because the answer is a vector. The result, if you change the order or if you displace the vectors, the result would not be equal. Your four fingers shows your direction. You go from A, as you can see in this picture, to B, and this would be the C. In here you go from B to the A, and this would be the C. This C is coming out, this C is going down. And as you can see, we show, actually this is some extra thing I want to show you. If something is coming, if a vector is coming out of the page, it's going to look like this, because you imagine vector like an arrow, right? If it's coming out and you look at it, you see the point coming out. If it's going down, actually imagine it's a arrow and it has these feathers or whatever in the back, so it's going down, you can see the feathers, so it's going to look like this. So this one is going down, this one is coming up. And again, you practice it with your own right hand. This is very important. Practice with right hand from A, because this is A times B. So from A, the four fingers goes to B. This is the C. In here is B times A. So from the B, the four fingers goes towards the A, and this is your C. So, you can see in here that they are not equal because you're dealing with sine, and the sine of theta does not equal sine of minus theta. If you draw a perpendicular, this is sine of theta, and this is, if you this is of course sine of theta. If you draw a perpendicular to the sine, this would be the sine of minus theta. And you can see these two are not equal. They are equal in magnitude, but they are not equal because they are negative of each other. If this is, for example, 2 over 3, this is minus 2 over 3, so they are not equal. So in that case, you can also see something else, as this is the smaller angle, this is the sine of it, this is the bigger angle, and this is the sine of it. So the bigger the angle gets, the bigger the result gets. And I want to show you this a little bit more. Imagine this is A and this is B. A to B, this would be C. So the C is going out. Now imagine you have another situation. Let's say this is vector M and this is the vector N. So M times N, this would be the C, which is actually going down. If I show it like this, the red times blue, the C would be going down. Yeah, I show it in another direction. Let's use these colors. Actually, this vector times this vector, this would be the C. In the opposite, if this vector times this vector, this would be the c. So the c is going down.